Oh my god! Oh my god, it's starting. So I mistimed this. I was the song, the OCR Land theme tune. Do you like my little OCR Land picture there? The OCR Land theme tune was supposed to end as my coffee finished, but unfortunately it came to an end a few seconds before. So I apologise for completely mistiming that. However, let me just get my thingy up. There we go. Thought we could start off by having a look at the spec so that we've got an idea of what needs to be covered, so that you guys can say, "Oh, do that bit first, yeah," or "Do that bit last," or "Do that bit in the middle," or whatever order you want to do the stuff in. Quick question for those of you in chat. If I wanted to store data using Python and I wanted to maintain the order of that data, what data structure might I use? That is a question for you to answer in the chat while I go and grab my coffee, and I will scroll down to the stuff you need to know. There we go. I'll be back in a second. I'm back. No one's answered my question. That's all right. I assume you don't know. Or maybe you didn't hear me. I don't know. I assume you can hear me. Give me a thumbs up if you can hear a word that I'm saying. Oh God. Do you exist? Are you alive? Are you a thing? Tony, can you hear me? There's a YouTube symbol. Okay, cool. That'll do. Thumbs up. Good. Right. Okay. Cool. So, do you know the answer to my question? If I wanted to store a bunch of information in order using Python, how might I do it? Do you know the answer to that question? Yes, a list is the correct answer. We would use a list. Now, the exam board often it doesn't refer to lists as lists most of the time. It uses a different word beginning with A. What is the word that the exam board will use when talking about lists? Do you know? I feel a little... Is that better? Oh, is that all right? Oh. Arrays, that's right. Okay, so if you ever see the word array in the exam paper, just think to yourself, oh yeah, cool, lists. Yeah, the way that you access that is the same. So... let's have a look. What do we got? We have, these are the things that will be assessed. 80 marks. There's 80 marks in total. This is a non-calculator paper, so no calculators, because God forbid you should use the tools that you have been learning to use in order to answer questions. Don't ask. I don't know. So there's two sections, the section A and the section B. You've seen examples of this. We have been through a couple of section Bs. All questions are mandatory. That means you've got to answer all of the questions. Or, I mean, they're not going to hunt you down if you don't answer all of them, but you should have a go at all of the questions. What that means is there's no sort of optional questions where it's like, choose the one. God gave us tools, let us use them. God did not give us the tools. The pioneers of computer science like John von Neumann and Edgar Dijkstra, who are among gods. Let's be honest. They are gods among men. They gave us the tools. As well as countless other people that worked on those engineering projects, because it would be false of us to assume that one man or one woman was responsible for all the wonderful technology that we have now. Everything is lots and lots of people working together, and a lot of the time their names are forgotten. Okay, don't get into the habit of thinking that there are, just singular great people. There's not. There's lots. Everyone's great, and everyone contributes in some way. Yeah, so section A and section B. Section B is pretty much half of the paper. It says, it doesn't say here, but it says on the section B, you should aim to spend around 40 minutes on section B. And when you consider that there is only 90 minutes in the exam, I'm sure you don't need a calculator to work out what 90 minus 40 is. You can see that 90 minus 40 gives you 50, right? Which means that if they're saying spend 50 minutes on section A, 40 minutes on section B, they're not saying that. What they're actually saying is spend 40 minutes on section A, spend 40 minutes on section B, and then spend 10 minutes checking your answers, right? And if you pace yourself 1 mark per minute, then you should be all right. So check how many marks each question is worth. Okay. In section B, questions assessing students' ability to write or refine algorithms must be answered using either the OCR exam reference language or the high-level programming language they are familiar with. The high-level programming language that you are familiar with is Python. However, if you are more familiar with another high-level programming language, I don't think anyone's going to shout at you if you use that. I would suggest that you are all probably more familiar with Python than you are with any other high-level programming language. So my advice is use Python. Okay, use Python. Try and make it as syntactically accurate as possible. There's certain things that they may overlook. There are certain things that they will definitely not overlook. Quote marks around strings, for instance, that's something that ain't going to be overlooked because that's present in every single programming language. There might be a few things, but we'll cross that bridge when we come to it. Okay, so it says here, practical programming. All students must be given the opportunity to undertake a programming task, either to specification or to solve a problem or problems during the course of study. We have done that like literally throughout the entire course. Like pretty much every topic that we did, there was some sort of programming challenge based around it, and then we had a whole ton of time where we worked on that stuff. So you've had plenty of time to work on this. It's just a case of understanding how to apply that knowledge. And you should already be in a place where you can kind of do it. You maybe just need a few sort of little tips. That is the point of tonight's stream. These are the sections of part 2. So all of this stuff is going to be assessed in the exam. Algorithms, that includes the binary search, the linear search, the bubble sort, the insertion sort, and the merge sort. Now, as we went through those fairly recently, I'm assuming you probably don't need any help with them, or if you do, it's only going to be minor bits, right? So I'm going to sort of like, they are low on my list of priorities, right? Programming fundamentals. This is like the building blocks of programming, which, as I understand it, includes basic arithmetic, adding, subtracting, dividing, multiplying, all of that. Creating variables, manipulating those variables, changing the values of variables and things like that. Selection, that's your if statements. Iteration, both count controlled and what's the other one? Conditional. So that's your for and while loops, and use of subroutines and functions. So functions and procedures. That's what programming fundamentals is all about. Producing robust programs. If you remember, we spent a good amount of time putting in those checks to verify, or rather validate, user input. So checking to see if data that has been entered falls within specific ranges and stuff like that. Okay. That's what producing robust programs is all about, trying to make the programs not easily broken by idiot users. Boolean logic, that's your and, or, and not gates, and multiple connections thereof. And then programming languages and integrated development environments, that's sort of like the features of the IDE and stuff like that. Okay, so have a think over these sections. I want you to just like post in the comments, if you're able to post in the chat, what areas you would maybe most like to go over. What I'm going to do is I'm going to scroll down the spec so that we can have a look, and then we'll get our hands dirty doing some programming, because I'd imagine that's the area that you probably want to go over. So if I just scroll down here. So yeah, don't wait for me, by the way. Just type that stuff into chat, because I'm about like 5 or 10 seconds ahead of you. Type that stuff into chat, and then right, we've got some Boolean logic. Cool, we can go over some Boolean logic. Anything else? Robustness or Boolean. Okay, so that's 2 calls for Boolean logic, so maybe we'll do that. Right. I'm going through, this is the detail in the spec of the Paper2 stuff. IDEs, want to go over IDEs. Okay, we can go over, I can show you some features of IDEs. PyCharm, we'll be using the IDE PyCharm to have a look at some of those features. Right, computational thinking. You all know what abstraction is, right? Can anyone give me a definition or an explanation of abstraction? Post that in the chat while I carry on talking about this stuff. Decomposition, and I don't mean like rotting vegetables and stuff like that, not that kind of decomposition. Problem decomposition, what does that mean? If you've got an explanation for that, type it in the chat as well. Algorithmic thinking, that's something that I can't really teach you over and above what I've already tried to embed across the whole of the course, right? But I will try to sort of explain the process of algorithmic thinking as we're working through some of these algorithms. Hiding something unnecessary. Yeah, in terms of abstraction, getting rid of unnecessary data. Getting rid of unnecessary data in order to simplify a problem. Okay, there's a number of different ways that abstraction could be used. The example that I always gave you guys was maps. If you look at something like Google Maps, it's not exactly how the Earth appears, because it's not photographs unless you turn on the satellite view, but even then it's not entirely accurate. But a lot of the detail you don't need. If you've got a vague idea of the sorts of things that are on a map, then that conveys all the information you need. Obviously, the downside of abstraction is if you abstract too much information, get rid of too much information, you're going to lose accuracy. Do you know what decomposition is, though? And it's okay to say no, you don't, because I can remind you. While you're typing that message in, I'll go over this next bit. Identify the inputs, processes, and outputs for a problem. Structure diagrams. Create, interpret, correct, complete, and refine algorithms using pseudocode, flowchart, reference language, high-level programming language. You need to be able to read the pseudocode that the exam board gives you, but you can write it in what's it called? Python. Okay. Identify common errors, traceables. Right. So you don't know what decomposition is. I would go so far as to say you do know what decomposition is, but you probably have, you probably know it under a different name. Okay. So yes, Robert Martin, breaking down a problem into several smaller problems that can be solved separately and then combined. Okay. And the thing is, if you start off with a massive problem, right, you break it apart into some smaller problems. Each of those smaller problems could, in theory, be broken apart into even more small problems. If you just bear with me a second, I've got an example of this in action. So just bear with me while I pull that up. It's actually from one of my A-level lessons, but it's still fairly relevant to you guys. Let me find it. Here we go. Right, have a look at that. Okay, so to give you an example about what we mean by decomposition, obviously this is not code. This is an abstraction, right? A structure diagram, if you like. We want to create a system for a mobile phone. The overall big problem is mobile phone, right? And so the other thing this is a very old diagram made in the days before smartphones were really a thing, so I apologize for that. So we've got mobile phones, yeah? What can a mobile phone do, or what does our simple mobile phone system need to do? We need to be able to make voice calls. We need to be able to send text messages. We need to be able to keep contacts in a phone book. Okay, so to start off with, we've broken the great problem of create a system for a mobile phone into 3 smaller problems. Create a system that can send and receive text messages, create a system that can send and receive voice calls, create a system that can store information in a phone book, right? If we focus then on voice calls, we can further break that apart into 2 smaller problems. There is the problem of receiving voice calls, and then there's the problem of sending voice calls, yeah? If I just focus on this problem of sending voice calls, then I can further break that apart into these 3 problems here. We need some way of capturing the voice as it is spoken. We need some way of converting that voice to digital signals, and we need some way of transmitting those digital signals on the phone network. And you can keep on going. You know, you could choose one. Like so, converting voice to digital signals. Okay, you're going to have to split that into some further problems. Like, what sort are we going to use? Some sort of compression algorithm? Are we going to send it in raw binary format? What do those signals look like, and how to structure that? Okay, does that make sense, right? That should look reasonably familiar to you guys in terms of, like, we've got this big problem, we've started breaking it down, right? Remember when we had those challenges like creating the... Was it the Hangman game that I did with you guys, or was that a different class? I lose track of who I've done these things with. But we broke it down into user input, displaying the board, and then checking the game rules. Okay, so there were those 3 sections, and then we further broke those down. Does that make sense to people now in terms of problem decomposition? Feel free to ask a question in the chat, or just give me a thumbs up if that makes sense. Gaming J, yes. I'm trying to work out what J that might be. Perhaps Joe. Who knows? Who knows? Right, let's go back here. So, identify the inputs, process, and outputs for a problem. Fair, yeah, blah, 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 blah. Good. It's parrot, okay. Yeah, for some reason, you know, call me crazy, I assumed that it would be someone whose name began with J. Yeah, whatever. Okay, so identifying common errors. Identifying common errors. You know what? We will get our hands dirty with that when we start coding. I won't ask you too many questions about that. So if you have a look in this box over here in the guidance box, required, produce simple diagrams to show the structure of a problem, subsections, and their links to other subsections, right? So that sort of thing. Although I think it's highly unlikely that you would be required to create all of that from scratch. It'll be more like that one we saw on the example paper where it's a fill in the blanks sort of deal. Okay. Identify syntax and logic errors in code and suggest fixes. We could potentially have a look at some examples there. Create and use trace tables to follow an algorithm. That might be something that you are maybe less confident with. But you should be familiar with these flowchart diagrams as well. Okay. Obviously, just drop a message in chat if there's anything specific you want me to go over that you see in here. Searching and sorting algorithms, I think we're pretty hot on those, right? The binary search, the linear search, bubble sort, merge sort, insertion sort. Worth noting, you do not need to know the code for those algorithms. You do not need to know any reference language for the merge sort or anything like that. You might be given the code for the bubble sort and said, yo, what algorithm is this? Or you might be given code for the insertion sort and I said, hey, what algorithm does this represent? Okay. So you need to be able to potentially read the code. You won't be able to have to write the code. Okay. You won't have to be able to write the code, I should say. Okay. You will definitely need to be able to apply those algorithms, but I think you guys are pretty hot on that, right? So let's have a look at programming fundamentals. Use of variables, constants, operators, inputs, outputs, and assignments. Do you know the difference between a variable and a constant? The clue is in the name, but I want to know if you guys know. You also need to just drop it in the chat while I'm talking. The use of the 3 basic programming constructs used to control the flow of a program. Sequence, remember that's a bunch of instructions executed in order, one after the other. Selection, that's your if statements. Iteration, that's your loops. Count controlled loops are for loops. Conditional loops are while loops. You need to know the common arithmetic operators, plus, minus, multiplied, and divided. There are some others as well that you need to know. Okay, but we'll go over those in a minute. The common Boolean operators and, or, and not. But you want me to go over logic, so we'll go over logic in a minute. Okay. Data types, difference between integers, real numbers, which are called floats in Python. Okay, so if you see the word real, that means float. So that's a number with a decimal point in it. Yeah, Booleans, characters, and casting. Casting is where you convert from one data type into another. Variable is something that gets assigned a value, but a constant is the value. So it's sort of, right? So the variable is a location in memory that you give a name to, and you can change what is stored in there. Okay. A constant is the value which stays the same throughout the program. Okay, so yeah, constant value is does not change. So pi would be stored as a constant. Just be careful if you say a variable is variable. You try to avoid using the same word to describe what a word means, right? So a variable, and it's important to understand that when we talk about variables in computer science, we are not talking about the values themselves. In science, you would talk about the variables. You'd say, oh, this variable is 5. Now it's 7, right? In computer science, the variable is the location in memory where it's stored, okay? And you can change the value. So think about variables as boxes that you can put information into. Constants do not change. And also be very careful when you are explaining what a constant is, because it's tempting, isn't it, to say a constant is a variable that does not change. But that doesn't make any sense, because variables, by their very nature, their values are going to change, right? So if you say constant, it's a stored value which remains the same throughout the program. Okay. Right, additional programming techniques, use of basic string manipulation, the use of basic file handling operations, open, read, write, and close. We will go over those again because I think it's been a while. The use of records to store data, the use of SQL to search for data. Records, by the way, are similar to dictionaries in Python, so we'll have a look at that. The use of SQL to search for data. I went over that fairly recently, but I will recap that just in case. All you need to know is the select command. Select something from something where something, and it's dead easy. I guarantee you it's super easy. The use of arrays. We did a lot of work recently on one-dimensional arrays and two-dimensional arrays, so I'm hoping that makes sense still in your head. We've gone over the difference between functions and procedures. I'm looking at this, and based on what we've done recently, I'm feeling fairly confident, but obviously it's not me sitting the exam, it's you guys. So shall we, you mentioned building robust programs. Okay, so anticipating misuse, authentication, all of this stuff, we will go over that. All right. Right. Should we start off with some Boolean logic? Let's hop into it. I've had enough sort of like waffle about what you need to know. I think it's probably best if we just hop into it. Okay. I am going to use logically. Just bear with logically. I'm going to try logically in my browser. Can you see that all right? Right, and I'm going to have some inputs here. I'm just going to drag a bunch of inputs on here and label them. and then I will have an output, and we will add some gates. All right. So all you need to know for logic is you need to know AND gates, you need to know OR gates, and you need to know NOT gates, and you need to know how they behave. And you also need to know how they behave in conjunction with each other. Right? So here we have our A and our B. If I feed A into a NOT gate, right, and then connect the other end of the NOT gate to the light bulb, what is going to happen if A is turned off? It's going to turn on, that's right. NOT gates are often known as inverters, because whatever the input is going into them, the output is going to be the opposite. If A is turned off, so A is false, output, I'll label that Q, because we normally label that Q. Okay. So if A is on, Q is off. If A is off, Q is on, and vice versa. Okay. Now the same thing applies regardless of what's going into these things. I'm just going to disconnect. Oh no, what am I going to do? I'm going to disconnect that. Let's have another gate. What kind of gate is this? I mean, it says on the screen, but pretend you didn't see that. AND, right? So AND gates have at least two inputs. As far as you guys are concerned, your NOT gates have one input. All of the other gates have two inputs. Okay, so I'm going to feed B into there, and I'm going to feed C into there. And then I'm going to feed the output in there. So we can see with B and C both off, the output from B and C is also off, right? So what combinations of B and C will turn Q on? What would I need to set? Is there more than one? Is there only on if all the inputs are on? Yes. That makes sense to everyone? Look, if I turn B on, you can see this input is on, that input is off, which means the whole thing is off. They have to both be on. If that one's on and the other one's off, nothing. If that one's off and the other one's on, nothing. If they're both on, the output will be on. Okay? So let's just throw a spanner into the mix here. I've got my AND gate there. I am now going to take my NOT gate. The output from the AND gate is going into the NOT gate. Okay? Now, there should be three combinations of B and C, which end up turning the light bulb on when I connect it. What three combinations of these two switches will produce the light bulb output being on in this logic gate? Zero, 1, 1, 0, 0, 0. Yeah, you're absolutely right. Look, if I connect that now. So it's the opposite of an AND gate, right? This is actually, we can combine that into a single gate, which looks like that. It's a NAND gate, but I don't think you need to know that at GCSE, so we won't worry about that. Let's delete that. So you can see here, with both of them off, the output from the AND gate is off, and that's fed into a NOT gate, which means that it ends up turning on. If I turn B on, the output from the AND gate is still off, right? So the output from the NOT gate is going to be on. If I turn both of them on, suddenly the output from the AND gate is on, so the output from the from the NOT gate is now off, right? A tip for you on this one. If you're given a compound logic gate diagram like this, right? One thing that you can do is sort of work your way backwards from the end. Okay, so if we start off here, we want to know when this is going to be on. So if we say, right, this needs to be true, this needs to be true, this needs to be true. Okay, we've hit a NOT gate. When is a NOT gate outputting true? Okay, when it's the input is false. Okay, cool. So we know that this going into the NOT gate has to be off. So we trace it back here. And now, oh, we've got an AND gate. When is an AND gate off? Right, and then you can work out what combinations from there. Does that make sense? I always find it better to start at the end and work your way backwards through the gates. Does that make sense to people? We may never know. We may never know. I'm going to tentatively continue, assuming that it does make sense. It makes sense to one person. Makes sense to one person. I think I'll do it in order. Yeah, I mean, I obviously I can give you tips and stuff that work for me. If you've got ways that work for you, use those ways. As long as they get you to the correct answer, that's fine. That's fine. Okay. So let's do. I'm going to move D up here. Let's do A and D, but we will use this gate. Quick, turn that off. What kind of gate is this? It is not a NOR gate. You're close. It's not NOR. It's OR. It's just OR, right? Let me show you the NOR gate. So the one on the bottom here is the NOR gate. The one on the top is the OR gate. Do you notice the difference between them? So OR was the correct answer, right? NOR was the incorrect answer. Yes, you are right. Yes, you are right. Mr. Despicable Me. Okay. Do you notice the difference between these two? Just by looking at them. Tiny circle, yes. The tiny circle in front of it, right? You do not need to know about any gates with the little tiny circle in front, okay? By the way, that little tiny circle is because that NOR gate is like an OR gate with a NOT gate in front of it. And if you imagine this NOT gate being pushed into the end of that little circle is the little circle there. But I'm just going to get rid of that, okay? And let's get rid of this as well, okay? When you are drawing OR gates, make sure that you draw the curved back, right? Curvy back, straight back and curved back OR, okay? And try to get like the curved lines at the front going to a point as well. Notice on the AND gate, nice and round. OR gate, curvy but pointed at the end, right? So decide which of the two forms you prefer. Curvy or pointed at the end, or nice and round, okay, and associate them with whatever will help you remember them, right? And is curvy and is curvy with a flat back, or is curved to a point with a curvy back. I don't know how best to remember that, okay? But let's connect this up. Let's connect that up now. I'm just going to delete that connection there. If I connect this to the output, like that, what are the conditions in which the light bulb will be on? A or B on, right? So if I turn A on, look, it's on. If I turn B on, look, it's on. What if they're both on? If they're both on, is it going to be on or off? Going to be on or off. You've got a 50-50 chance of getting this right. It's going to be on. It's going to be on. If they are both on, I know it's called an OR gate, right? But it's an inclusive OR gate. So if A is on, or D is on, or they are both on, the light is on. The only time the light is off with an OR gate is when they are both off. If you want them, if you want it to behave the other way, you would need to use an exclusive OR, which is this one. Okay, so if we have that and that, I will show you the difference here. If I turn that on and connect that with the exclusive OR gate, you turn on one input, it turns on. You turn on the other input, it turns on. If you turn both of them, it turns off. Right? That is not, not what you need to know. Okay, you need to know the standard OR gate. All right, if A is on, or B is on, or D as I'd called it here, or they are both on, the output is on. Right, that's the one thing that you definitely need to remember. Okay, got it? So, and they have to both be on, right? Or the only time it's off is if they are both off. Right, I'm going to draw a logic circuit now. I'm going to build a logic circuit, and you guys are going to tell me. What that logic circuit is. All right, let me build it. Right, there's my logic circuit. You know what? I'm going to rearrange the letters just so that it makes a tiny bit more sense. Right. I want you to tell me if you were given this logic circuit and you were asked to explain what that logic circuit would be in terms of A, B, C, and D, what would it be? I want you to look at it. I want you to have a think. And if you can, remember those special symbols, the special symbols for and or. I'm going to type them into the chat, right? So that is and, right? And that is or, okay? I want you to use those symbols to produce a diagram, produce the definition of what this diagram represents. Hopefully that makes sense to you. Or just write it on paper, and then in about 5 minutes I'll explain it to you and you can double check. If you don't want to type it in chat, just write on a piece of paper, write on the back of your hands, carve it into a dead snake or something, I don't know. Wherever you can write it down. Use brackets if you need to as well. You might want to use the process of decomposition for that as well. Okay, so I'll give you about 5 minutes to do that. And then I'll give you the answer. Not A and B. We've got, so how is How is the A? You've got not A and B, and then you've got C or D. How are those related to each other? There's a missing symbol in there. We've got not A and B and C or D. That looks correct. That looks correct to me, right? So the process of breaking this down, right? The bottom path here, there's C or D, right? Okay, cool. So we know that there's a C or D, so we could put that in brackets somewhere. You know what I'm going to do? I will. You see my little panel at the side here? So I know I've got a C or D in there somewhere, right? At the top, I've got an A and B as well, right? This is not my final answer, by the way. This is me like sort of going through the motions of working it out. I've got an A and B at the top there, but then that A and B gets fed into a NOT gate, so the whole thing is not A and B, right? Not A and B. Just a quick rearrange to make it in a more logical order. So we've got a not A and B. We've got a C or D here, and both of those are being fed into the AND gate. So we end up with not A and B and C or D. Okay, not A and B and C or D. I hope that makes sense. By the way, those three symbols, sorry, I forgot to show you the not symbol. I just assumed in my head you could remember it. But yeah, the not symbol, it's that one there. It's the one to the left of the 1 key on most keyboards. Okay. I mean, this, by the way, this circuit that I've given you here, way more complicated than the circuits that they'll give you. They normally give you about 2 gates, but here is a rule of thumb. Okay, here is the rule of thumb. For every input that you have, you are going to have a letter. Look, I've got A, I've got B, I've got C, I've got D. So I've got my A, I've got my B, I've got my C and my D in my solution, right? And every gate that is on here is going to be one of my symbols. So I have 1 gate, 2 gates, 3 gates, 4 gates. So I'm looking at 4 symbols here, right? We've got and, we've got or, and we've got not. Each of those symbols will match to one of these gates, right? So you can sort of puzzle it out. I've got an and gate, cool, I need one of those and symbols. I've got a not gate, I need a not symbol. I've got an or gate, I need an or symbol. I've got another and gate, so I need another and symbol. And then it's just a case of making sure that on either side of those symbols you are listing the inputs. Is there a logic symbol for the ones like NAND? Yes, there is. Although it's not easy to type on a keyboard. If I just bring up my amazing whiteboard here, where is it? Where's it gone? You've got the NAND symbol. So that's your AND symbol, right? That is NAND. Yeah. You've got your OR symbol. That's OR. That is NOR. Annoyingly, that is XOR. And if you want XNOR, that it's that. That makes sense? Hopefully that makes sense. Let's get rid of that. Okay. So the other sorts of questions that they are likely to ask on logic is they might give you a logical expression and say draw the circuit from that, right? So if you go to, this is the website that I'm using, by the way. Just paste that in the chat. There it is. It's going to appear before I even say it. Look. It's already there, and that should be appearing on your around about now, except I don't know whether that's synced in or not. I don't know. So that's the website, right? I'm going to give you a logical expression. I want you to try and construct the logic circuit from that expression. Then I will build it myself, right? And then if there's no further questions, we'll move on from logic. We'll do a bit of programming. Okay, so here is the logical expression that I want you to create. Let's have... ooh, let's try this one. Right, there it is. I will put that on my, what's it called? On my little text window as well. Let's get rid of that. There, right? Have a go at building that. Be careful on this. Look at where the not symbol is and think about where your not gates need to go. Okay? So have a go at building that. I will give you, let's say 5 minutes again, maybe 5 minutes, maybe not that long. I'll give you 3 minutes to have a go at constructing that in Logically. Then I will build it myself. You can compare it and then you can say, yes, I got it right, because you're going to get it right. I believe in you all. While you're doing that, I'll tell you what. Do you want some more of those banging tunes? This one's called Laser Pack. Let's find out what that's like. Just play that while you're working it out. Is that playing? Oh, there we go. What a tune! Just drop a message in chat if you've done the circuit. So just so I know when you're finished, I'm not just sitting here like jamming to this like mid-quality royalty-free music. By the way, all this music is available for free at incompetech.com. I believe it's all written by the same guy, Kevin MacLeod. It's all licensed under the Creative Commons license, which you should know about if you haven't already forgotten all of the stuff that you needed to know for Paper 1, because Paper 1 is now done. One person's done. How about this music, though? Feels like I'm in a nightclub in 2007. 2007 nightclub. It goes on a little bit though, doesn't it? Right, I'm gonna stop that now because it's giving me a headache. Right, let's do the thing, shall we? Let's do the thing. Yo, this music be banging. Owen, how's it going, my man? Hope you are. Hope you're living the life right now. Just sketched it. That's fine. That's fine. Right, let me. I'm gonna delete my logic gates. Yeah, not bad. Did you get your show, Dan? Did you get your black belt? I assume you did, because if you didn't, then you deserve a whooping. There we go. Right, okay, so we've got A or B to start off with. Remember, anything in the brackets? Not yet. Okay, keep training. Train hard. Train hard. I believe in you. I believe in you. We've got A or B. So we need an OR gate. There we go. Cha-ching. Hopefully this summer. Good. I ordered a new gi the other day. My gi got a little bit torn up in the washing machine, so I've ordered a very expensive new one. Right, the next bit here on the other side, not C or D. So we need another OR gate, and we are going to need a NOT gate, but we've got to be careful about where that NOT gate goes. The NOT gate is just before the C here, which means that we are going to go straight out of C into the NOT gate, and then out of the NOT gate into our OR gate, right? D is coming straight out from D into the OR gate. And then both of those are going to be joined together with an AND gate like that. Okay, that there is our circuit. Does that look similar to what you guys have drawn? I imagine if you got it wrong, you probably got the NOT gate in the wrong place. Just double check. Let me know if that makes sense, if you want me to go over any other bit of logic before we do a little bit of coding. Makes sense to Tony. Anyone else? Anyone else exist? I don't know. It says there's 6 concurrent viewers. We're going to get some solid results this year. I just know it. Such dedication from my students. Cool. Excellent. Right. That pretty much covers it for logic. Simple logic diagrams using the operators and or not. Truth tables. Did you want to go over truth tables? Look, we've got some example truth tables here. Do you want to quickly do some truth tables, or are you happy with truth tables? One of those viewers is someone that totally does not need this revision. But hey, this just shows dedication to my craft, doesn't it? You know, what other teacher gives up 2 hours of their Wednesday night to do a revision stream for like 5 people? None of them is the answer. None of them do that. Okay, so Tony's good. So we don't need to go over truth tables, right? You happy? We don't need to go over truth tables? Let's do coding. Let's do coding. Yes, let's do coding. Are we ready? PyCharm. PyCharm is an IDE. As we do some of this coding, what we're going to do is I will go through some of the features of the IDE. Okay. Elb. What does... Oh. It's someone... What's that called? Dab. That's right, yeah. Remember that? Remember dabs? What year is it? It's 2014. Is that? Anyway, just gonna have a look at my at the spec again, and find out. Right, you wanted to go over building. Like defensive design or robust programs. I also wanted to go over file handling operations. So let's just quickly do some coding. To start off with, should we write to a file and then read from that file, just so that you know how that goes. There's 2 ways of doing it in Python. Okay, so is that text big enough? Right. File handling. This part of the IDE that I am using is called the editor. The editor allows me to enter code. Not only does it allow me to enter code, it also color codes it for me so that I can easily see errors. File handling. What are we going to do? Let's create let's ask the user to type something in, and then we will stick it into a file and we will store that file as a text file. Easy, right? So all of our input statements are going to look the same. They're going to have the name of the variable that we're going to store, and they're going to say equals input, and then they're going to ask the user a question, right? So let's call it user text. User text equals input. Please enter some text. Some text. Okay, so we're asking the user to enter some text. Okay, notice how the editor has color coded this for me. Look, my command appears in this gray color. My variable name appears in this gray color. My command is in purple, and then my string is in green. Okay, that helps us differentiate it from things like integers. For instance, if I created an integer called myint and assigned it a value 9, you can see that the value 9, it's been recognized as an integer and not a string, so it's colored it in blue. Right? We will come back to that in a moment. So what we want to do is we want to open a file, and we want to write that user text to a file. Okay. So let's do it. We are going to say file equals open, and we need to give it a name. We will call the file, I don't know, mydata.txt. YXY.txt. Okay, TX, I can't type. There we go. And we want to open it in write mode. If we open it in write mode, then it means that we are actually able to write to it. The way that we write to it, now what we've done, we've opened the file and we have stored a reference to that open file as the variable file. We need to remember to close the file at the end. So don't let me forget to close the file at the end. Okay, so what we're going to do is we are going to write to the file. We're going to say file.write, and then in brackets, user text. File.write is like print, but for files, right? Print outputs on the screen. File.write will write stuff to our files. Okay, so I've opened the file, I've written some data to the file, and now I am going to close the file. That's it. Okay, if I run my program, I won't get any output from it. Okay, but I should see a file get created. If I just open my project folder now, I don't know how easy it is for you to see that text there, but if I just run this, it's asking me to enter some text, so I'm going to type in Mr. Smith goes the extra mile for his ungrateful students. Right, there we go. You see, as soon as I hit enter, the program exited, but a new file has been created. Okay, a new file has been created. And if I double click on mydata.txt, you can see all of that stuff that I typed in is in my file. Okay, however, there is a slight issue. If I run that program again, right, it's asking me to enter some text. What shall I enter? Computer science is the best subject. No cap. Okay, so it then it will still write to the file, but let's have a look at my file. Oh no, where has my other data gone? Okay, the data that I originally wrote has disappeared and been replaced by that new data. How can I get my data to be written onto the file without erasing everything else that's already in there? Does anyone know? Either make a suggestion or say that you do not know so that I know, and then I can tell you. Open the file in append mode is correct. So you see over here, we've opened the file, we've given it a name. Okay, that's going to open a file. It's going to create a file if it doesn't exist. It's going to open the file if it does exist. That if we change that write mode to append mode, remember the word append means add at the end. So now if I run that program again, I can enter some more text and I can say This is some more text. Okay, if I look at my file now, cool. You can see though that it's added that on directly to the end. The difference between file.write and print is that print adds a new line at the end. File.write does not. So it might be worth each time we do a file.write just adding on or concatenating on a new line character here. That means that every new entry into the file is going to be added on a new line. Okay, so if I run that code now, this should be on a new line. Okay, now by the way, I've already pointed out this one feature of the IDE here, which is the editor, which has syntax highlighting, which makes me able to see instantly whether my code is nonsense or not, because it's got all this color coding, so I can see what data types things are and everything else. I've also got a file browser over here, so any files that are created by my programs I can instantly access. And down here I have an area where the code is output. So right away there's three amazing features of an IDE, this all-in-one development environment. If I just go to my data now, what has happened here? This should be on a new line. It's not on a new line. What is going on? Why has that not put it on a new line? I genuinely don't know. What I might try is if I do a separate file.write. Oh, hang on a minute. No. You need a new line before writing the text. Yeah, you're right, actually. Putting it after the text. It means that the next time I run it, though, the next time I run it, it should be on a new line. So if I run it now, this will definitely be on a new line. Right, if I enter that now, let's go back to my data. Yeah, it works. Okay, it would have worked all along as well if I'd have deleted all of the stuff in the in the file. Okay, so I'm just going to comment this stuff out. By the way, in PyCharm, as you know, hold down Control and press / to automatically comment out of your codes. Okay, very useful for just toggling code on and off when you're doing some testing. So I am going to now open the file again. File equals open my data.txt. And we are going to open it this time in read mode. Okay, and then we're going to say contents equals, we're not going to use file.write this time, we're going to use file.read. Yeah, like that. And then once again we need to close the file. Right, so we've opened the file, we've read the contents of the file, we should now be able to print those contents of the file. Contents, okay, and if we do that, run that code, cool, there we go, we've got all of the information from the file. Okay, I genuinely don't know what sorts of questions they are going to ask around file handling. I would imagine that they might ask you to write some code which opens a file with a specific name in the right mode and then write some data to it, maybe. Okay. Hello, Millie. Good to see you. Yeah, as I said, do not know what sorts of questions they're going to ask you, but the way that you access files is really simple. You know, open the file equals open, and that's kind of the same way that you would do an input command, right? My data equals input, yada yada yada. Look, we've got this user text equals input, please enter some text. File equals open my data.txt, and then you got file.write or you got file.read. You got to remember to close your file at the end. How am I doing? I'm doing amazing. I'm doing even better now that you're here with that amazing. Is that a woodpecker avatar? I can't quite make that out, but it looks incredible. So yeah, wonderful. Right, is that good for file handling? Do you want to do some more building in robustness to your programs? I know, Tony, that's what you wanted to do, yeah? Oh God, everyone's dead. Anyone there? Anyone hear me? Right, I'm going to get rid of that. Let's do some... Anybody out there? You exist? You real? Yep. Can you do with opener? Yeah, okay, so I'll just undo what I just did there. So if you want to... The better way, if you like, of doing this is using the with syntax, right? So instead of doing file equals open, yada, 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 another way that you could do it is like this, right? You could do with open mydata.txt like that as file, yeah? And then inside here, contents equals file.read. That is probably a preferable way of doing it. Okay, that's a preferable way of doing it. If I just comment that stuff out. But in terms of execution, that's identical to this. It's preferable because all of the stuff that you do in this indented block is going to happen while the file is open. And as soon as that's done, as soon as you exit the indented block, the file automatically closes. Okay, so the syntax is pretty similar. Okay, you're still using that command open with open mydata.txt, r as file. Okay, so what that is doing, it's opening the file and it's still assigning that that variable as a handle to your open file, but it's set to automatically destroy that that handle, and therefore the open file, not destroy the file, but destroy the connection to the file, automatically close the file as soon as this lot is finished. Okay, and obviously same would apply there. Use whatever method you are happiest with. Okay, well, if that's with open mydata.txt, yada yada yada, then use that. If you prefer to go the long way, file equals open, do your stuff, and then file.close, you can do it that way. One thing to bear in mind is that this method is very Pythonic. Okay, and the reason I point that out is because if they give you some example code, it will not be written in Python. It will be written in the OCR reference language, and the OCR reference language has a structure closer to this than this. Okay, so I think in terms of your Python programming, it's more useful to know this. In terms of what to expect to see in the exam, there's this. So you'll be expected to read something similar to this. You can write it whichever way you want. Does that make sense? Am I making sense now? Everyone's dead again. Brilliant. Okay, so if I carry on now doing some making programs a little bit more robust, I'll also introduce you to the debugger as well. Maybe we'll see how that goes. Right. So let's say let's see what sort of things might I do. Okay, here's what we're going to do. Right. Ask the user to enter a number. In the range 0 to 24 inclusive. Okay, so 0 is valid, 24 is valid, anything outside of that range is not valid. And then what we're going to do, we are going to multiply the number by 15. Multiply by the number by 15, and we are going to check to see if the result is even. Is that going to work? Maybe. I don't know. I'm making this up as I go along, right? Those are our 4 steps. Okay. So what we can do is we can write the code, and then we can look at potential ways where the code might break. Okay, and we can look at how that code could break and how we can anticipate that and how we can build in some robustness. Okay. So to start off with, ask the user to enter a number. Well, that's easy. We can say number equals input. Please, you know what, I'm just going to get rid of that so it's a little bit easier to see. Please enter a number, a number between 0 and 24. There we go. Okay, so the user is going to enter a number between 1 and 24. Now, to start off with, I'm just going to do it without putting any checks in at all, just to show you how easy it is to break stuff like this. Okay, so then we can say number equals, or we're going to multiply it by 15, yeah? So number times equals 15. And then check to see if the result is even. How can I check to see if a number is even? What operator am I going to use? That is my question for you. And one thing that you might want to consider, we know a number is even if it will divide by 2 with no remainder. Tony's straight in there with an answer. Yes! We're going to check to see if mod 2, the number mod 2 is equal to 0, right? Yeah, if we're using the modulus operator, if we're checking to see if the number mod 2 is equal to 0, then we know it is even. There is another way, by the way. Do you want to see the other way? I'll do it in the Python console. So, for example, if I say let's say my number is 13, right? I've got my number is 13, yeah? If I convert that number to binary, and check the very last digit, if the very last digit is 0 or the very last digit is a 1, we can tell whether it's odd or even, right? So one way that we can do it is we could say bin num check the very last character. There we go. False, right? The very last character of our binary representation of the number 13 is not equal to 0, it's equal to 1. If I just change num to 12, and then that will equal true. That's another way of doing it. I would recommend using the modulus way. Right, so check to see if the result is even. We are going to use an if statement. We're going to say if, obviously I should have put down here, output the result. So if number mod 2 equals 0, we are going to, yeah, we'll do 2 separate print. I'm not going to confuse you guys by doing some fancy voodoo. Let's just do print the number plus number plus is I've just thought of a way that I could make this more efficient, but I'm going to do it. I'm going to do it the long way, and then I can show you how we can improve efficiency. Right. So if number mod 2 equals 0, the number is even. Else, we're going to print the number and yeah, that's another way of doing it. Using a bit mask. The other way of doing it would be something like this. If you want an esoteric way of doing it, you could do shift it to the right by 1 space, and then shift it back by 1 space, and then check to see if that is equal to the number, right? If it's even, that will be true. If I just change that to an odd number, that should return false. There you go. That's the other way of doing it. Bit shift once, bit shift back. Does it equal the same thing? You know, there's lots of different ways of doing it, and it's fun to find out new ways of doing it. And then you can go on r/programmerhumour and you can type them all in and gain all the karma in the world, and everyone will love you. Allegedly. Okay. Right. Okay. So we've got our program here. There are a number of problems with this. I'm going to say right now, there are a number of problems with it that I've deliberately built in. Okay. Out of interest, can anyone spot any potential either logic or syntax errors in that code? Right. I'm going to give you a couple of minutes just to go over it. Okay. Have a look at that code. We've got, yeah. Why do we need int input instead of just input? I mean, it's mostly a rhetorical question, because I'm not expecting you to be able to explain the whole thing in the chat, but it's something I want you guys to think about. Reasons. I'll tell you the answer. Whenever you use Python input, whatever the user types in is stored as a string. If we want to do some sort of manipulation, mathematical manipulation, we really need it either as an int or a float. Okay. Now, this line 8 should be fine. Line 8 should be fine, because we're going to convert that. If we convert that number to an integer, obviously we're fine. If it's still a string, it's going to duplicate it 15 times. Yeah, and you might need to try and use a try statement around it to see whether we can convert it to an integer. That's another thing that we're coming back to. That, however, that is anticipating a runtime error as opposed to a direct syntax or logic error. Okay, so we're anticipating runtime errors, but it's really good that you guys are thinking about this stuff already. You know what? Before I start making any changes or corrections, I'm just going to run my code and see what happens. Okay, let's run the code and see what happens. A number. Give me a number between 0 and 24. I'll give you 10 seconds to enter a number between 0 and 24. Just type it into the chat. First number gets it typed out, and you will get that many V-Bucks. Are V-Bucks still a thing? Does anyone care about that? Robux. 6. Let's type in 6. Well done. You are the proud owner of 6 V-Bucks. They will arrive in your imaginary inbox any day now. Right. So we've got a traceback. We've got a syntax error, and the syntax error is triggered here. Note, the syntax error is not triggered here. So that means that line 8, that's executing fine. We run into problems when we try and find out what the modulus of a string is, because we obviously can't do that. Now, obviously, we know what the error is. Is it a scam? Everything's a scam. Modern life is a scam. Modern life is a scam. But that's Paper1 stuff, man. You know, don't worry about phishing attacks. It's fine. Social engineering? No, Paper1. We're doing Paper2 here. However, we know what the error is, but if we didn't know what the error was, we could use the debugger, right? I'm going to stick a breakpoint in here. A breakpoint allows me to run the program up to a specified point and then pause and step through and look at the various different values that I have stored. So if I just run that in debug mode now, we've run up to line 7 and we have paused. Okay, if I step into the next line of code here, look, it's flashed the console because it's asking for an input. I'm going to type in my number 6 again and then go back to my debugger. So I can see that number is 6, and it also tells me that number is a string, right? So if we're sort of like on the ball, that should make us think, oh, of course, that's where things are going wrong. But if we still haven't noticed that that's where things are going wrong, we can step through to the next line. Oh, now we should notice that something's wrong, because now our number is equal to 66666666666666666666666666666666666666666666666666666666666666666666666666666666666666666. Was that enough sixes? That should have been 15 sixes, right? And then if we step onto the next line, well, that is where we get our traceback. Look, you can see the exception has happened there. Not all arguments converted during string formatting. Oh no, there's our traceback. Okay, so another feature of the IDE, the debugger, which allows you to step through your code line by line and check for errors. Look, this is me teaching you multiple things at the same time. What an amazing teacher. Vote Smith for Teacher of the Year. So we've already said we're going to convert that to an integer, right? So number equals int input. By the way, this is one of those places where I don't think the exam board will mark you down if you forget to convert your inputs to ints. Don't quote me on that. I'm just saying that if you do forget about it and then at the end of the exam you're talking with your mates and they're like, oh yeah, do you remember to convert to an integer? I don't want you to suddenly panic and cry yourself to sleep at night. I mean, I wouldn't do that anyway. It's not worth it. Okay, so we've converted that to an integer. By the way, I'm going to write it in my little notepad here. Converting between different data types is called casting, right? If you hear the word casting, that means converting from one data type to another. For example, using int to convert to an integer, using str to convert to a string, using bool to convert to a boolean, using list to convert to a list, and so on and so forth, even though technically speaking list is not a data type, list is a data structure, but Python sees it as a native type. So we will, what's the other one? What have I missed? Int, string, bool, and what's the other one? Love this delay, man. It feels like I'm on some sort of satellite link up, or I'm broadcasting from the moon or something. Float, yeah. The exam board will refer to floats as real numbers, right? They will refer to them as real. So just be aware of that. Okay, if you see the word real, it means float. Okay, so that's your casting. Okay, so now we have converted the number to an integer. In theory, our stuff should work, right? So should we run the code again? Let's run the code again. Okay, here we go. Give me a number between 0 and 24. Again, first number gets the dubious honor of me typing in their number. 6 again, like it. Like the consistency. I like the consistency. Oh no, I messed up. Here we go. If I put a 6 in there. Okay, we've got another problem now. We've got another problem. It's on a different line this time. Line 10. Line 10. The number plus number is even. Type error. Can only concatenate string, not int to string. We've got the problem the other way now. Okay? When you print stuff out, if you're concatenating stuff, it has to be a string, so we would have to cast that back to a string before we print it out, okay? In terms of syntax errors and stuff like that, I don't think they're going to ask you specific questions like this. They're more likely to ask you logic questions, logic error questions, okay? By the way, I've taught you this syntax, haven't I? I taught you that syntax, right? I would recommend not concatenating commas, and the reason is what you're essentially doing is feeding multiple arguments into the print statement. You get more fine-grained control over concatenation, or through variable injection like this. I mean, look, you're right in the fact that you could do it separated with commas like that. I tend not to do that. I don't know, maybe C++ programmer, force a habit, you know. But this really, some sort of like variable injection formatting like that would probably be preferable anyway, because you don't have to worry about the converting the different variables. Okay. Right. So that is that's another method of formatting your strings there. So that F implies that you're sticking a floating point number in there. The thing is, there's lots of different ways of doing it. Again, I don't think the exam board is going to notice the difference between something like that and the syntax correct version. I would use that method personally, but yeah, you could I think you could do this as well. I think that might work. Don't quote me on this. Don't quote me on this. I'm just going to check it. Let's check it out. Do. Give me a number 50. No, I'll do 5. Do 5. The number 75 is odd. Is 5 times 15 75? I don't know. What has happened there? 5 times 15. Yeah, 75, right? Yeah. Is the I for integer? Yes, it is. So multitude of different ways of doing it. If I just go back to how I did it before, I had %i and then at the end there I had my my thing there. If I run that, why is that looking like an error? There we go. The number 75 is odd. Of course, because I've put in a number which is obviously going to be odd. Is any number times 15 even? I don't know. I'm losing my mind here. I'm losing my mind. Let's just double check that this actually works in that format. 5. So that works. Let's just double check that I and then squiggly brackets number works. This might end disastrously. It might end in failure. Yeah, that totally doesn't work. That's because I know why. Because it should have been like that. I think that's the format. Is that the format? Is that how it works? Yeah, there we go. That's the other way of doing it. That F means format, and then you can inject variables in there by putting them in between squiggly brackets. Cool. I feel we've all learnt something today. Right. So we fixed the obvious errors, right? We fixed the syntax errors. We fixed the logic errors. Okay. You know what I'm going to do? I'm going to change all of that to make it look similar to each other. Do you want to see the way I was going to make it more efficient? What I was going to do is inside this I would just have a variable called status or something like that, or odd even, and I'd put it as either odd or even, and then I'd just have a single print at the end. It doesn't matter about that. Right, so what have we got now? We've got a program which ostensibly works. There's still a way to break it though. Can someone suggest one way of definitively breaking this program when we run it? Any ideas? Do you want me to show you? How about this? Right. If you type in any text, anything which is not a number, we can't convert it to an integer. You know, so that's a potential problem, right? So what we need to be able to do is check to see whether they've actually typed in something that looks like a number. And there's two different ways of doing it. We could use a try except, but I think there's a slightly nicer way of doing it. And also it allows me to teach you the general forms of like building in robustness. Okay, so here's what we're going to do. We're going to set up a Boolean flag called valid, and we are going to set that initially to false, right? And then we're going to have a while loop, while valid. Oh, sorry, while not valid. So while not valid, we are going to ask the user to enter a number. We are also not at this stage going to convert it to an integer, because there's a couple of checks that we need to do on this number to make sure that it is valid. Okay. First of all, we need to check to make sure it actually looks like a number, right? So the first thing that we're going to do is we're going to say if number dot is numeric. Is numeric is a function in Python that checks to see whether what you've typed in is a number, right? If there's anything that is not a number, it's going to say nope. You know, so if it's not a number, we are going to, sorry, if not number dot is numeric, we want to print you need to enter an actual number, exclamation mark, right? And we are not going to set valid to true. Okay. What we might want to do then is immediately exit the loop and not bother checking to see what the range is. We're not going to exit the loop. I mean, we're going to sort of go back to the start of the loop. So we can use continue. Okay. Don't need an else in there. We are now going to have a second if statement. No, we are now going to convert that number to an integer. Right? Because I don't know how many of you are familiar with continue. I have showed it to at least one of my classes, and I can't remember which one. But what continue does, it basically says, right, stop processing anything else in this current iteration of the loop and go back to the top of the loop. Okay, it's kind of similar to a return in a function, but it basically means just go back to the top of the loop. Okay, this is not the only way of doing this, by the way, but it's the way that makes the most sense for what we're doing here. So we're checking to see if the number is not numeric, then what we want to do is we want to print to we want to tell them to enter an actual number and then go back to the top of the loop. All right. There is another way that we could do this. We could check to see if the number is numeric and then have another if statement. We could then do the conversion. In fact, that might make more sense to you guys. Show you what I mean. I'll show you what I mean. So if the number is numeric, then what we can do is we can convert the number to an integer. Yeah, this is going to make more logical sense to you guys. Right. So if the number is numeric, we can convert it to an integer, and then we can check to see whether it's in the range, right? So we can say if number needs to be between what, 0 and 24. So we can say if 0 less than or equal to number, which is less than or equal to 24, okay, then we can set valid equals true. Okay, cool. And then we're going to exit the loop. Otherwise, we are going to print the message, print number must be within between, let's say, between 0 and 24. Hope this is still making sense to everyone. Okay. And then we've got an else from our first thing here. No, what are you doing, Carl? Else. We are going to print you must enter a number, exclamation mark. Okay. So we have a basic, maybe not the most efficient validation loop in the world, but it's going to check to see if we've typed in our numbers properly. Okay. So for example, you can see what if we trace the output of this program, right? We're setting valid equals false while not valid. So valid at the moment is false, which means we are going to continually loop round until valid is set to true. There's only one place here where valid is set to true. So first of all, we ask the user to enter a number between 0 and 24. If that number is not numeric, we're going to skip over this whole first section of the if statement. Okay, and then we are going to just print you must enter a number, and then we're going to loop all the way back round. We're going to ask them to enter a number again, right? If the number is numeric, first thing we're going to do is convert it to an integer. And then we are going to check to see if that integer lies between 0 and 24. If it does, we set valid to true, which means we are then going to exit that loop, right? If not, we set valid, we keep valid as false, and we print out the number must be between 0 and 24. Hopefully that makes sense. If I run my code, please enter a number between 0 and 24. Well, first of all, no way, man. If I type in some text, it says you must enter a number. Okay, cool. I'll enter a number. Minus 65. Okay, you must enter a number. Okay, the fact that it hasn't recognized that minus 65 is because the minus sign is not numeric. So that's why it's done that. If I put in, I don't know, a really big number like that, number must be between 0 and 24. Okay, so if I put in the number 6, there we go. 6 times 15 is 90. The number 90 is even. I'm not entirely sure what's going on with my stream here. I'm hoping you guys are still alive out there and you can still see what's going on. When it comes to input validation, there's multiple different ways that you can do it. Right, but what you need to be able to do is use Boolean flags to say, right, start off with things are not valid, and then you check each of the different areas of validation in turn. Okay, so for this one, we need to enter a number. Okay, cool. The first thing we want to do is check to make sure that it is a number. If it's not, then we can tell the user it's not a number and we loop back round. We don't set valid to equal true. Okay, if it is, okay, we've got one of our things ticked off, so let's check the next most important thing on the list. Because we know that the number is numeric at this point, we can convert it to an integer without worrying about our program crashing. Okay, once we've converted it to an integer, we can then check to see if that integer value lies between our valid range. If it does, we can set our flag to true, and then we can exit this whole loop and get on with the rest of the program, knowing that what the user has typed in is going to work and is not going to cause us further errors. But if it is not within that range, then we can just print out another message for the user. Valid will still be false. We loop back round and we ask them again. And the idea is that you keep on asking the user until you're able to set valid equals true. Does that make sense to people? Are you even able to still see me? I don't know. My stream seems to be paused and constantly like catching up with itself. So just give me a high five in chat or something like that. Who knows, man? Who knows? I'll assume that does make sense. Okay. So remember, 3 types of errors. Syntax errors. That's where your code does not work properly. Your system does not understand the code. Those are the easiest errors to spot because your code will not run, right? The program crashes, so you can easily find those errors. Fixing them, not always easy, but finding them definitely is. Logic errors. Your programs will run, but they probably won't do what you expect them to do, right? They won't do what you expect them to do, and therefore they're more difficult to track down. The way to track down logic errors is to step through your code line by line. Use the debugger or use a trace table to go through your code and work out which lines are being executed and what the current values of your variables are. The most difficult errors to deal with are runtime errors because they occur, there's no errors in your code. They occur due to like user input or things that might happen during the course of your program running. Okay, so runtime errors you have to anticipate. What we have done here, we anticipated the runtime error of our number not being converted to an integer. properly, right? We anticipated the user typing in something that didn't look like a number, and so we have tried to eliminate that runtime error. Okay. When it comes to robust programs, creating robust programs, it is all about looking at the format that the inputs need to be in. How do you check to make sure that the inputs are in that format? And that is that. I have no idea if you guys are still able to see me. You know what I'm going to do? I'm going to try something dangerous here. I'm going to try refreshing my streaming dashboard here. Has that done anything? Has that worked? I don't know, man. I don't know. Something's going on with my internet connection. I am uploading fine. My download doesn't seem to be working. Let me just try something here. Okay, that kind of works. Yeah, do not know. Do not know. Right, I am going to call it a night there. I hope this has been useful, and I hope that it didn't just sort of like descend into nothingness at the 1 hour 55 mark. If you have any further issues, drop me an email or come and see me at break time or after school. Bear in mind I've got parents' evening after school tomorrow, so I'm not going to be able to see you after school tomorrow much. But please do come and ask. Keep on practicing. All of my videos are still on the what's it called? Google Classroom. So yeah, that is that.